So good morning students. Today's our topic is about limit and continuity. What is limit? In calculus, limits refer to the behavior of a function as its independent variable approaches to the specific value. Basically, for example, let's say that here x approaches to any certain value, that is a or something. Then what is the behavior of function fx? The behavior of function gives us the limits. Now coming to the continuity. What is continuity? Continuity, on the other hand, focuses on the smoothness and connectedness of a function. That we can draw a graph of a function, and when it does not break, that is, we do not need to pick up the pen, then we can say that the given function fx is continuous at that point. Now, what's the limit of a function? A function is said to have a limit L as x tends to a, written as such, that is, limits extending to a, fx is equals to L if given epsilon greater than 0, however small, there exists a positive real number delta depending upon epsilon such that fx minus L modulus is less than epsilon for all those values where x minus a modulus is lying between 0 and delta. That is, this is the definition of limit of a function. Now we have talking about the continuity of a function at a point. A function is said to be continuous in a given interval if there is no break into the graph of the function in the entire interval range. That is the same thing which I have already explained, that while drawing up the graph of any given function to us, like it is sin x, cos x, whatever, these are the continuous functions, sin x, cos x, by the way. And yes, a function is said to be continuous in a given interval if there is no break in the graph of the function in the entire interval range. Definitely, we do not need to pick up our pen while drawing the function's graph. Now, its definition is a function f is said to be continuous at x tends to a if given epsilon greater than 0, however small. Epsilon is a very small positive quantity. There exists a positive real number, say delta, again depending upon epsilon, such that fx minus f of a modulus is less than epsilon for all those values of x minus a modulus which are lying between 0 and delta. So, this is the definition of continuity of function at a point. This is the definition which we have to use while solving our sums, and it could also be written as such. F is said to be continuous at a if and only if limits x tending to a fx is equals to f of a. This is the definition of continuous function. Now coming to the next slide. Yes, we have limit and continuity, both of two types. That is, limit is of two types, that is left limit and right limit. Now coming to continuity, this is also of two types, that is left continuity and right continuity. Now, left limit. What is the left limit? A function. These definitions are similar to the main and basic definitions we have learned about limit and continuity. But what about left limit? The only difference is that here x would approach to a negative. That is, a function f is said to have a limit, left limit L, as x tends to a negative, written as limits x tending to a negative fx is equals to L if given epsilon greater than 0, however small, there exists a positive real number delta depending upon epsilon such that fx minus L modulus is less than epsilon for a minus delta less than x less than a. That is again the same thing, that here the only major difference is that x converges to a negative limit, and here in this definition we have seen that this definition is true only for those values of x which are lying between a minus delta and a. This is an interval which can be shown by a minus delta comma a, and the values of x should be lying in between this interval, that is a minus delta and a. Only those values of x which are lying in between a minus delta and a would satisfy this condition, and it would give the definition of left limit. Now coming to the right limit. A function f is said to have a right limit L as x tends to a positive. This is the minor difference. Now for left limit we have x converges to a negative, while in the right limit we have the x converges to a positive. Now it could be written as limits x tending to a positive fx is equals to L. Now, by the definition, if given epsilon greater than 0, it is a small positive number, there exists a positive real number delta of epsilon such that fx minus L modulus is less than epsilon for x lying between a and a plus delta. Now coming to the next slide, that is we have left continuity and right continuity. There is also the same minor difference which we have is a function f is said to be left continuous if and only if given epsilon greater than 0, however small. There exists a positive real number delta depending upon epsilon such that fx minus f of a modulus is less than epsilon for these values where x is lying between a minus delta and a. Symbolically, it can be represented as such, that is limits x tending to a negative, fx is equals to f of a. Now, for the right continuity, we have the definition that a function f is said to be right continuous if and only if given epsilon greater than 0, again which is a very small positive number, there exists a positive real number delta depending upon epsilon such that modulus of fx minus f of a is less than epsilon for all those values of x which are lying between a and a plus delta. Here the interval we can say is a and a plus delta, right? Symbolically written as such, limits extending to a positive, fx is equals to f of a. So these are the definitions of left continuity and right continuity. You could take their screenshots also, the concept about limits and continuity. That's all.